Let's take a look at this first population graph, the hare lynx data. I'm going to make this a little bigger so it'll be easier to see. Okay, so hare lynx data on the x-axis, we have time, we have years, and above this, the introduction says that the graph below is from the Canada's Hudson Bay Company from 1845 to 1935, and it shows how many varying hare or rabbit, type of rabbit, essentially, and lynx pelts were brought in by trappers. And the key on this, over at the right here, you can see the hare is in blue, the lynx is in orange. And the lynx is a type of big cat. Okay, so then it gives some more information about biotic and abiotic factors. So x-axis is time in years, and y-axis is number in thousands, and that is numbers of pelts, the skins from these animals that trappers had trapped, that were brought into the company for counting, and they kept good records. Okay, so questions that you need to answer. Let's take a look down below. Okay, first it's asking about the peaks in the snowshoe hare population. Okay, about how many years apart are those? And then it also asks about the lynx population. So let's look at the hare population first, the blue lines. Okay, where are these peaks? For some reason, when I look at this graph, it just seems like it's more even and easier to read here with single peaks and everything. So I look at a peak in blue here. So, before 1925, but not much. Let's just call it roughly 1920. And this one here is before 1915, roughly 1910. Going back a little further, we have the blue peak a little before 1905. It's about every 10 years. And you can do the same thing for the orange line and see how to answer that question. And you just have to choose from 1, 5, 10, 20, or 70 on each one, so that shouldn't be too bad. And then it asks if the hare or the lynx is the predator of the other animal here. One's the predator, one's the prey. So which one is doing the eating, and which one is being eaten, the prey? And it says there's a helpful and logical rule of thumb here. Predator follows prey. So that's kind of cool because you can think of the one that's doing the chasing, following the prey that's going to get caught. But that works with the graph too. The lines, the trends should follow like that too. And here again, I think it's easier to see out here. It seems like what I'm seeing here is the blue line drops, and then the orange line drops. Blue line rises, and then the orange line rises because we have time increasing off to the right. So we see the difference in the blue first, the hare, and that's followed by the lynx. So if predator follows prey, means lynx is the predator following the hare, which is in blue, the prey. So hopefully that helps on that graph. Okay, second graph. Well, see, then some of these questions here are what you think. Just think about what happens in nature and what do you think a logical idea would be here, and just try to back up whatever you think with some evidence, some logic. Okay, I don't think you asked about this graph, but the third one here, exponential or geometric versus arithmetic or linear growth. Okay, so let's see, on this graph, it says, okay, I guess you just asked about reading the graph. You can always let me know if you need more here, but in reading this graph, in fact, I thought there was a different question here that I'm seeing. but I'll look for that in a second. Basically, the different kinds of growth. The population size is off to the left on the y-axis. The generations are at the bottom. Okay, you can just think of people generations if you want. And it's said that arithmetic growth is also called linear growth. Line. So that's straight line. And exponential growth is this other one that has a curve, kind of a J shape. Okay, I scrolled down a little farther, and I'm seeing this number 9, summarize in your own words the difference between arithmetic and exponential growth. It says, looking at the shape of the lines, this isn't to the right, or it isn't anymore, tell which our population follows. So it's this graph up here. And it actually talks about why these look the way they do. So arithmetic growth is adding the same amount each time period. And if you look at this, you can see that's true. And if you double from like 2 to 4 in generations, it looks like, let me see here. That's hard to read on this without lines. Let's not go that way. Okay, so you're adding the same amount in each time period. And we could kind of check that out. On arithmetic, you are seeing with every 2 generations the same amount of increase vertically in the direction of the y-axis. So that makes sense. Here you have change starting out very slowly, and then it just skyrockets. Okay, in contrast, exponential or geometric growth occurs by multiplying rather than by adding. There's an example here. Okay, I'm going to stop there, and I'll let you tell me what more you need, if anything.